I think I was muted. How's that sound now?
Yes, that's perfect. Thanks. Continue.
I had muted myself.
I figured. No problem. And we're seeing your desktop and not the presentation. Huh?
Okay, good. Let me change that. How's that look?
Yes, perfect.
Great.
Go ahead.
Okay, so I guess you can hear me. Good afternoon, everybody. I'm not there, but I'm happy to be here in Trinidad using the virtual connection. So all protocols involved have observed. I'm not sure who I'm talking to, everybody, but welcome and thank you for having me. So today, my role here is to basically talk about windows and doors and their impact on hurricanes and things like that. I'm the vice president at Domus in the sales department. And after my presentation, I believe my colleague Terrence is going to do a Windows smash test. And then, of course, we'll take some questions and answers, and hopefully we can answer all your questions. So windows and doors, what should they provide? Obviously, there's a very large aesthetic appeal. You know, when you build a house, you want it to look good. When you buy a car, you don't put on cheap wheels. You want to put on some nice wheels. And of course, you want long-term functionality. When you buy a house, when you build a house, because you're living in it for a long, long time, you want to make sure that it stands up there, brings light in, of course, keeps rains and bugs out, etc. And of course, up the islands, hurricane wind load protection is very, very important because this is becoming a reality for all of us. Security from hurricane and missile impacts, energy efficiency is also important, sound attenuation, and a reasonable cost value above functionality, because of course that does make a huge difference. We have found life cycle cost is a big issue when someone is taking a 20-year mortgage. You don't want to have to be changing out windows in 10 or 15 years because of sea blast, because they're falling apart, or because they're fading. You want to hope that they could last at least 20 years. The styles and types should be appealing, of course, create a feeling of pride and contentment. And the finishes, we hope, should be as maintenance-free as possible. I know living up the islands, we all suffer from sea blast. Trinidad, not as bad as the rest of you, though Tobago is quite bad and our east coast is very bad, Miaro. But up the islands, sea blast, I know, is a very real issue. It attacks metal, it attacks products, as well as UV, of course, and moisture. So the Caribbean climate, we all know, is very harsh. So you do want to try and build a building with windows and doors that can give you as least maintenance as possible. It is kind of a commonsensical thing to have. These are some examples of some of the windows and doors we've done up the islands. Those are double doors, those are awnings, there's a patio door. I'll just go through the slides very quickly. Here, of course, in the Caribbean, everybody has beautiful views. So, of course, that was discussed in the previous presentation about large windows, and he's dead right. They have to be built properly, have to be reinforced properly, and have to be able to withstand hurricane forces. This is a project in Trinidad that we did. You can see multiple stories. These are all PVC products. Again, just some idea of doors. Again, this is interesting. This is a large window because, of course, someone has a beautiful view, and then they've got some smaller windows below for ventilation. So one of the things that architects and designers can do is you can, make the windows very bespoke, very individual. This is a specific window that the client wanted to have a nice view, but in case current went, and it does happen up the islands, he could open up the bottom windows, and of course you can get some natural ventilation coming in. And again, just another example of a fixed window in the middle and some awning windows either side. And again, patio doors as well. As you can see, this is quite a large 6-panel patio door structure. Patio doors are obviously, again, very common up the islands and in hotels and in commercial buildings because of the wonderful views you guys have up the islands. Again, another example of a patio door, but this time a 4-panel door. Now you can see the previous slide, the tracks are recessed in the ground. I've got to be careful with that because how does it drain? If you look at these, the tracks are actually raised. And if you notice, there is no awning or roof in front of this patio door, so it does get the weather. So you do want to be able to get the water to drain off. And in a hurricane, of course, you have to have those raised tracks. If you are going with hurricane-rated patio doors, you would not recess the tracks at all because the wind forces drive the water horizontally. And in fact, it can actually make the water climb an inch or two up into the tracks and then into the house. So you do need to have those raised tracks if you're going to try and have hurricane-rated products. And again, just another sort of. So let's move it on. So the right material matters. Wooden still being built. It still happens. It's been going on for a long time, but of course, wood has its pluses and minuses. It does deteriorate rapidly due to rotting, termite infestations, and twisting. It does require continual maintenance. It has to happen all the time. Wood has to be painted, has to be sanded, has to be varnished. It doesn't provide a lot of security, can be broken into fairly easily, and they can fail quite easily when subject to hurricane impacts and wind loads. They don't seal well. And basically, we don't recommend using wood on exterior wooden doors. Even though they're being used, we don't recommend it. This is an example of something in Trinidad on the North Coast. They built these fancy townhouses for some people, but they put in wooden windows. And of course, rain falls on the sash. It always drains down the glass into the bottom corners. The joinery is not perfect. The seals aren't perfect. The water settles there. And these windows are about 3 or 4 years old. So look at that. Forget a hurricane passing, because they would of course fail in a hurricane, but the windows themselves can't even stand up to the Caribbean climate, this is just penny wise and pound foolish. And the same project, another window, you can see the bottom frame of the window is completely rotted and fallen off. And of course, this is in Tobago again, where we had some wooden batch boards just completely corroded and falling apart. And again, we have a wooden trellis that was built in Trinidad, and you can see it wasn't properly protected and it's rotting away. Steel, there are no accepted specifications for steel fabricated windows fabricated in the Caribbean. Aesthetically, they can appear rough and clumsy. They do rust quickly, require continual maintenance. I own steel windows here in the tropics, and every year at Christmas time, my windows are quite old. I have to sand them, I have to paint them, I have to maintain them, because once they start to rust, it never ends. They don't seal well and perform poorly in hurricanes, and they've not got very good thermal performance in terms of keeping the heat out. I mean, obviously steel conducts the heat beautifully, so if you do have eastern facing walls or western facing walls where you get that sun hitting them, of course, that steel does the heat from the sun can radiate straight through the steel, adding to the fact that you're heating up a building and making it uncomfortable inside, adding to the air conditioning load and all those types of things. Here are some steel columns in Tobago just rusting away beautifully on the east coast of Tobago. Again, the same columns rusting away beautifully. I don't need to tell, I think you guys up the islands what happens to steel and salt and rust. This is a window in Trinidad again on the northern elevation, because most of our weather comes from the northeast, of course. So northern elevations tend to get most of the weather. This is the ground floor of a two-story structure. And you can see again, water falling on the glass, resting in the corners, and the steel starts to spoil. As you can see there, it's been spoiling quite nicely. And in fact, the spoiling has actually cracked the glass as well. So you can see what happens to steel windows, again, not even subject to hurricanes, but just normal Caribbean weather. Aluminum windows are aesthetically pleasing. Though aluminum extrusions are available throughout the Caribbean, aluminum is being used a hell of a lot. They're easily manufactured. They don't require a lot of skill to actually make them. A saw, a screwdriver, and a measuring tape. When I last went to Ghana, there were a lot of Chinese laborers underneath the houses, and you're driving past the roads and you're watching people building aluminum windows on their houses, just putting them together very basically. There's a wide range of finishes and colors, so aluminum does give that positive aspect that you can have lots of colors. There's a large existing base for manufacturers. There are a lot of aluminum manufacturers everywhere. And of course, architects, developers, consumers are very familiar with aluminum products. It's quite interesting that when Domus was building its factory here in Chaguanas, and the architects was doing the drawings for us. When he presented us with our drawings, he specified aluminum windows, and we're a PVC manufacturer. So we had to tell the architect, no, we're going to go with PVC. So that's just because aluminum has been around for a very long time. The entrance cost to manufacture UPVC is much higher, of course. You have to weld the PVC, you have to cut it. And there are few quality manufacturers to compete against. So, we have a huge investment here in Trinidad to build a PVC plant. Aluminum is historically less expensive, can be manufactured in small spaces, as I said. And it is basically more competitive than UPVC, but that's now changing. Of course, aluminum prices are going up. And also with the advance in technology in PVC, the profiles have been getting cheaper and cheaper. So, PVC has been coming down in price and starting to become more competitive towards aluminum. That's the new paradigm now. Aluminum does oxidize and erode in high humidity and high salt environments, sea blast. What is very interesting, and a lot of people don't seem to understand this, is that you have an aluminum frame, an aluminum window, but often the hardware is attached with metal screws. And in fact, some of the mounting screws into the concrete, if they're being used, are also metal. So of course, once you have two dissimilar metals and you have moisture, which you do have in the cribbing, you get electrolysis, you get corrosion. We had a situation in Trinidad where a commercial building had some aluminum windows installed by the sea. This is in Tobago, and it was quite a heavy blow was going on, but by no means a tropical storm. And the steel screws going into the concrete had given themselves up, had corroded completely, and the window just blew in. Luckily, it didn't land on anybody because it was a high window, but the entire frame just blew out and ended up inside the building. And that was just from using poor construction practices and people being unaware of what happens with when you have steel and aluminum in the same building, in the same construction. Of course, aluminum extrusions are cut to raw metal, so the corners do eventually leak. And the other thing which we found is the glazing is typically installed using rubber gaskets. And of course, the cribbing, heat, and sun shrink and crack those gaskets. I've seen it all over the cribbing, all over the cribbing. After a couple of years, the gaskets start to shrink. They start to dry rot, and then the seal is now being compromised. And it's impossible to provide security without burglar proofing, and because impacted laminate glass can be easily removed if you're using rubber gaskets. And there's a total lack of impact resistance to this. When we went up to St. Martin after the hurricanes passed a few years back, there were quite a few of these European hurricane rated windows that used rubber gaskets, and all the windows blew out. So it's very interesting that the rubber seals don't do well in the cribbing. UV or sun or moisture really does destroy it. And of course, aluminum windows are normally painted, so of course they can chip, they can be scratched, and of course then you're exposing the raw aluminum, which starts to rust. Again, the thermal performance is not great in terms of keeping heat out. Again, it's a metal, so of course, like steel, it transmits heat. And of course, since COVID-19, aluminum prices have increased much more than UPVC. And of course, what's going on with the war in Ukraine right now and the world, it's a bit of a mess. And of course, aluminum does require a large amount of electricity to create when you're smelting aluminum. This is an example of some aluminum windows leaking. This is taken from the inside, so it's not sealing well. You can see the rubber seal there is already starting to go. Again, this is an aluminum frame that's on the ground floor of a two-story building. And you can see already you're getting the aluminum oxide and the corrosion happening on the outside. And that was interesting. Again, the corners cut to raw metal. That's just an example of what I was saying. PVC windows, we think they're clean lines. We think it's classier than steel. But to me, the real plus to go with PVC, it's inert. There's no corrosion, even in high salt concentrations. There's no maintenance. There's no painting because, of course, it's white through and through, easy to clean. And we weld our corners. So the corners are actually welded as opposed to cut to raw metal. So they cannot leak or deteriorate over time. This is something we've seen up the islands a hell of a lot, that UPVC is not all the same. We have a 20-year guarantee on our PVC because we buy from North America, but some of the PVC coming in from the Far East is not stabilized as well. It's stabilized with lead. The lead itself is not very stable. In fact, lead has been banned from the windows in North America now for quite some time. They use titanium dioxide and other UV inhibitors. But the stuff coming out of the Far East will fade, will change color. So again, if you're talking PVC, you need to know, where's it coming from? What's the quality? It can be easily reinforced with the way it's constructed. It often has chambers inside where you can insert aluminum reinforcing, which is what we do. It can absorb shock. Nicks can be repaired. I've actually sanded PVC with a 800 grit sandpaper. And of course, it has great thermal performance. So once we've had some buildings in Trinidad, commercial buildings that are getting very hot, the eastern sun is cooking them, and they had to change out the glass because they used just regular glass as well, which didn't have any thermal protection, and they went with PVC frames, which are inert. And then suddenly now the windows became a lot cooler. Basically, the equipment required to produce PVC windows is far more expensive, so it's tough to go into the business. There are more manufacturing steps involved. It's a slightly more complex window to build than aluminum. And historically, the highest quality PVC materials have been expensive, but as I said, that gap is now closing. 80% of the windows are white. It's very hard to carry 10 different PVC profile colors. So of course, you tend to stay with white. In North America, the majority is white, and that's primarily because it's a neutral color. So over time, when you want to change your curtains, you want to change your house color, you want to change your furniture, of course, white is a neutral color. So you have a clear color palette there. Climate change, I think, is a really big issue now. people thought COVID-19 was a hoax, and scientists agree that climate change has occurred and is occurring. And over the past century, the average Earth temperature has been rising. The average rate of surface temperatures has doubled since 1981, and water temperatures also increased, and the rate of increase is accelerating. And I think these changes we have already been affected in the Caribbean. I think we've all seen how the hurricanes get very strong very quickly. They tend to go from a Cat 1 to a Cat 5 in 2 or 3 days. And I think that's primarily the sea is hot. And of course, the hurricanes gain their strength and gain their power from the heat of the water. And of course, it's worrying for everybody in the Caribbean that, we think there's going to be more and more hurricanes, and perhaps maybe not so much the number of hurricanes, but the intensity. It's a terrible fear that for all of us that the Category 5 hurricanes are going to become more and more frequent. This is an example of the sea surface temperatures taken from different, different data sets, and it only goes as long as 2015. But you can see the end of the curve. It's going up. It's going in one direction. I think we all could admit that the sea surface temperatures are getting hotter. Global warming is making hurricanes more dangerous. Hurricane speeds are getting stronger and stronger. They're delivering more rain because more moisture, more heat. Storm surges are increasing. And of course, we all know about the economic impact of a hurricane when it hits the islands. And they're intensifying more rapidly. Irma and Maria were Category 5 hurricanes when they reached the Eastern Caribbean. So we all have to take real cognizance of this. For example, you can see Dorian, we call them super duper hurricanes. It's 190 miles an hour. Now, this is not peak, this is sustained winds. I think Maria was actually having gusts of over 200 miles an hour, incredible wind strength. But you can see there that, there's quite a few hurricanes in 2005, 195 miles an hour, 205, Rita, 180 miles an hour. So it's happening. The hurricanes are getting stronger and stronger. This is an example of, post-hurricane. Again, I don't think I need to stress to those present, because you guys live up the islands, what hurricanes can do. I mean, they can be so devastating. It's amazing. Look at that. This is just wind force, just destroying. Okay, I think, okay. So again, what is interesting is that wind load and wind speed, it's actually a logarithmic scale. If you look at the wind speed at 100 miles an hour, you can see the wind load is 25 pounds per square inch. If you go up to 200 miles an hour, which is only a doubling of the wind speed, you've now got 100 pounds per square inch wind load. So what's interesting, you've now got 4 times the wind load with just a doubling of the wind speed. So it is a logarithmic scale, exponential scale, should I say. And it's scary stuff. The wind loads on the buildings are quite incredible. And the previous speaker did talk about walls. Can you imagine those big windows without those corners not being properly reinforced? Odds are that those are going to blow out under 200 mile an hour wind loads, and the entire building fails. You also have the same issue with wind load and wind speed. You can see again at 100 miles an hour, the load on a windows can be 900 pounds, but at 200 miles an hour, 3,600 pounds. Now, what's really interesting is patio doors, of course, much bigger than windows. Look at the windows, 2,500 pounds. That's a ton of weight at 100 miles an hour, but you go up to 200 miles an hour, 10,000 pounds, 5 tons of weight. That's a truck. That's a truck sitting on your window. That's a 5-ton truck sitting on your window. If you haven't got windows, the glazing designed to take the pressure, the windows designed to take the pressure, it's going to fail. And also, again, you've got the roof lift forces versus the wind speed. What we've got here is that we're assuming that the wind load is at 75%. So again, if you look at 100-mile-an-hour winds, you've got 9,000 pounds of lift trying to lift your roof. And of course, if you've got a bigger roof, you're going to have 18,000 pounds. And again, at 200 miles an hour, a Cat 5 passing through, this is actually greater than Cat 5. You've got 37,000 pounds of lift trying to lift your roof. And if you've got a 1,000 square foot roof, which is only twice as big, you've now got 75,000 pounds of lift. So nature and physics, tremendous wind forces, really, really deadly stuff. As far as we are aware, there's no Caribbean-wide wind load specification. Something needs to be looked at. And we also feel surely hurricane wind load resistance should be established to meet the strongest recorded Atlantic hurricane wind speeds of 190 miles per hour, plus a safety factor. One of the things that we've been doing with our plant in Trinidad, and we have 2 engineers, Terry Ort, who's our CO as an engineer, and our vice president of production, who's based in Canada, has 30 years of experience, is also an engineer. We basically decided for our own internal purposes, we're going to try and build all our hurricane resistant and hurricane rated products to 200 miles an hour. That's going to be sort of our basic standard. This is important. There are 2 missile impact specifications that are out there. There's missile C and missile D. Basically, missile C is a 4-foot long 2x4 wooden missile that's projected at 40 feet per second, and that normally has to hit the window or door 3 times, and of course it mustn't fail. And then there's missile D, which is an 8-foot long 2x4. So of course the piece of wood has double the weight, double the inertia, coming out 50 feet per second, which is even faster. And this is the standard for most vulnerable Florida locations, or in fact what we call Miami-Dade spec. So the missile D is what we would call the full hurricane rated specifications, whereas missile C is what we call hurricane resistant. Some observations that we made after Maria Irma. Wind loads seem to cause the majority of hurricane damage in Dominica and St. Martin. And there was very little difference in failure rates from missile impacts between missile C and missile D rated windows and doors. And we really had to think about this deeply, what the implications were, because Dominica, for example, got leveled and they had to rebuild a lot of their houses. And the trouble that we were seeing is that Miami-Dade, missile D, windows, obviously the glazing has to be stronger. The laminate interlayer, for example, for missile D is 2.5 millimeters, whereas the laminate interlayer for missile C is only 1 millimeter. So the hurricane resistant or missile C specifications, we can go with a smaller frame, whereas the missile D, we have to go with a heavier frame. To cut a long story short, the high impact hurricane rated windows are expensive. They really are heavily built, whereas the missile C tend to be not as strong. And now what happens is that we had different grades of laminate glass, and in St. Martin, we had some people who bought the high standard missile D hurricane rated windows, but there were quite a few of our clients in St. Martin just went with the regular laminate glass thinking, well, that's all I can afford, that's all I want. And what we found interesting is that the boat stood up very well to the wind loads. And what we also realized, there weren't a lot of really large missiles flying around. So we found that the missile C, or the regular laminate glass, stood up really, really well as compared to the high impact. And that led us to the belief that, if you can't afford the expensive hurricane rated windows, the hurricane resistant windows are a good second place. And in fact, we've just finished supplying windows for St. Martin for about 300 or 400 low cost housing. And they went with the missile C for the cost savings, because basically it can take the same wind loading. It's just the missile impact test. Now, of course, if something really large, an 8-foot long 2x4 hits a missile C, it might go through it. It'll stop a missile D. But we found in reality, there weren't a lot of 8-foot long 2x4s flying around St. Martin. So, it's something to look at. This is the test for the missile C. So you can see no ripping or tearing. So that's what it looks like after being struck with three 4-foot long 2x4s. Quite impressive. And this is much, and of course, these can also take 200-mile-an-hour wind loads. Now, this is the missile D projectile, which is the Miami-Dade specs. Now, if you're a commercial building, if you're a hotel, if you're a government building or a commercial building, you could probably afford to go with the missile D or the high impact hurricane rated windows. But if you're a residential person, you don't have a huge amount of money, going with the hurricane resistant specs could make a distance, give you a high level of protection at a reasonable cost. So here's the missile D test. So we have come up with 2 hurricane resistant product lines that are simple and can be understood by everybody. As I've been saying, economical, hurricane resistant, which really came out of a worldwide test, a real live test that we didn't anticipate, that when we saw that our standard 7.5 millimeter laminate glass stood up to the hurricanes quite well, we suddenly realized there was an economical hurricane resistant. And notice we use the word economical and resistant. It's not hurricane rated. And then of course the high impact hurricane products. All hurricane resistant products will meet wind load resistance of 200 mile an hour. And the economically resistant products can withstand 3 missile strikes with a C, and a high impact is a D. So at least now we have come up with 2 options, and really it depends on your budget. Can you afford, because of course if you have the money, obviously going with the high impact hurricane resistant windows and doors makes sense because it gives you a high level of protection, more from projectile strikes, but even the economical hurricane resistance will give you protection from the wind loads. And we also feel that the majority of the damage comes from wind loads. So there are 3 basics of the high security hurricane resistant windows and doors. Frames, the mullions, the sashes, and other structural elements must be strong enough to withstand the highest wind speeds. And the glazing must be capable of surviving missile strikes and other impacts. And regular glass, of course, is going to fail very quickly. And the other thing that we've seen, and as a glazing, has to be secured to the frames properly to prevent the glazing from popping out. And I already discussed that. And we saw a hell of a lot of failures in St. Martin from the rubber gaskets. So again, we would strongly recommend against that, primarily because the Caribbean climate just destroys it. The rubber just does not stand up to the UV, which is harsh. The moisture, it just doesn't stand up. And of course, the other thing that we now feel, the glass must be glued in the frames with strong waterproof adhesives. And again, we walk into a hardware in Trinidad, you can buy 40 different silicones. We only use GE products. We use a product called Ultra Glaze, which is actually a structural glazing adhesive, and it's a silicone elastomeric product, and it has high tensile strength, and that's really the issue. You got to make sure that when that glass is hit, or in fact, even when the hurricane winds are blowing, the window doesn't blow out. And I think we have a product that has 149 pounds per square inch holding force. Now, we had another client of ours, had a house in Dominica right on a hill when Maria hit, and he had the high impact windows, and he couldn't get out in time because it caught him unawares. It came in so fast, as you all may know. And he told us he saw the glass in the window bending. The actual laminate glass was bending in with the force of the hurricane winds, but it didn't actually pop out the frame. So again, it's all about, as this seminar is talking about, houses being built properly. Windows and doors have to be built properly as well. If you just don't fix the glass properly into the frame, and you use a cheap silicone, or you use rubber gaskets which don't stand up well, they're going to pop out under hurricane force conditions. Maybe not a Cat 1 or Cat 2, but probably a Cat 4 or Cat 5, they're going to fail. And the other thing that we've seen a lot of is insulation. You've got to install hurricane resistant products properly. Fasteners must retain the strength for life. And I gave you the example in Tobago where these aluminum windows blew out just in under 25, 30 knots of breeze because the steel fasteners failed. So we have experimented over the years. First of all our fasteners, both for our window, but also fastening the windows to the walls, we use a high grade stainless steel. We actually use, I think, 3 or 4 grade stainless steel. But what we found is even in coastal environments where you have sea blasts, the stainless steel would start to leach, the stainless steel would start to rust. So we looked around and said, well, what can we do to raise the level? And we have quite a large offshore oil and gas industry here in Trinidad, and all the steel that's used in Trinidad is Teflon coated with a product called Xylon. So we've decided after testing, all our stainless steel fasteners are actually Xylon coated. We actually have to get them coated in Canada and then shipped down to us. But what that means though is that when you install a 20-year product, like the PVC window will last you 20 years, and you don't use high quality stainless steel Teflon coated screws, what's going to happen maybe 10 or 15 years down the line, depending on how well your window's been sealed, your fastening screws are going to give up. And of course, in a hurricane, that's when you're going to realize that your fasteners have corroded away and your window blows in. And then of course, once your window blows in, you've lost your house. So again, we recommend high-grade stainless steel fasteners, and Domus, not trying to push us, but we actually went with a Teflon coating as well, because again, the more protection you can have from salt and sea blast is what you want. And of course, fasteners all around the perimeter interval sufficient to transfer wind load. We've seen people install windows, a 4-foot window, 2 screws in the top, 2 screws in the bottom, and maybe 1 screw on the sides. Not good enough. We normally recommend the screws are 4 inches from the corner, 4 inches from any joint, if it's joining mullions, if it's 2 or 3 windows in a row, and then basic screws every 8 to 12 inches along the frame. We also use 3-inch screws because, again, you're looking at shear forces. As you know, when the wind is blowing at 200 miles an hour, it's trying to rip that window out. So you want to have shear forces. So a 2-inch screw we just don't think is enough. We like to recommend a 3-inch screw. And the other thing, which again, our previous presenter would be well aware, he didn't mention it, but when you're building your window opening, your masonry opening, those openings have to be loaded. You've got to make sure that when you drill your 3-inch screw into the window opening, it's loaded with concrete. Otherwise, if you have concrete blocks that are hollow and you put in your 3-inch screw and the end of the screw is floating in midair in a hollow block, of course it's going to fail. So make sure that's the case. And of course, the other thing that we also highly recommend is people like the chinks on the caulking, and they use the wrong caulking when they caulk the windows to seal them. They're acrylic caulks and they're internal caulks. We recommend 100% silicone caulking, at least on the outside of the windows, because of course the weathering, again, you're talking wind and rain and UV. And the other thing is that even when you talk about caulking, if you go into a hardware store, again, you might see 15 or 20 different types of caulk. Our recommendation is always buy the caulk with the longest warranty. Again, we go with GE, which has a 15 to 20 year guarantee on their caulk. So, penny wise and pound foolish. You put some cheap caulking and the caulking fails, the wind gets inside, corrosion gets inside, your window fails. The other thing which is interesting, of course, is there's different types of glass on the market. Tempered glass, regular float glass, and laminate glass. Now tempered glass is very strong, but the problem with tempered glass, one strong hit with an object and it shatters. Of course, regular float glass breaks quickly, and then, of course, laminate glass, the whole function of what laminate glass does is we actually pour our laminate hot between 2 panes of glass. It's liquid, and then we put it under UV lights and it bonds to the glass. So the actual laminate, which is basically when you think about it for a second, it's an acrylic resin. It bonds to the glass, and then of course we glue that glass into the frame. When it's hit, it cracks, but it doesn't shatter. The laminate does a number of things. One, it holds the glass together. 2, it takes the impact from an impact strike, as well as providing UV resistance and heat insulation and sound insulation. So actually laminate glass does offer a tremendous amount of benefits. So here's a short video showing you the 3 different types of glass. This is tempered glass. See one hit and it shatters. Oops, let me go back. Sorry about that. Let me go back, sorry. What have I done here? No, I have to go back another one. Okay, sorry about that, my friend. I'll have to let this play. So of course, these are extreme tests. In a hurricane, you're not going to have someone standing up there wailing on your window with a crowbar. Clearly, the other benefit of laminate glass is security. But you can see with the tempered glass how quickly it shattered. Of course, float glass breaks easily. And you can see with laminate glass, this is 5 or 6 or 8 multiple strikes. Now, what's interesting is that the glass cracks, but you know what's happened? The glass is still holding its integrity. So even if you do get a small projectile strike with your laminate glass, your window should not fail. As I say, the Miami-Dade test is 3 hits with an 8-foot-long 2x4, which is quite incredible. We had another homeowner who wanted to protect his house in Trinidad, and he asked 4 suppliers for laminate glass, for impact glass. But what was interesting is he tested them all himself. So this is actually an authentic video we put together, but the actual tests and filming were not done by Domus. But again, because a lot of people, and this will happen up the island, say they have laminate glass. And technically they're right. You know, what is laminate? I've seen laminate glass, which is a thin film just put between 2 panes of glass. It is technically laminate glass, but is it hurricane rated? And we've had this conversation with many of our customers. You know, someone is offering you impact rated glass, ask to see the test certificates, ask to see, has it been tested by Miami-Dade? Have they paid to have the glass tested? What is it tested for? What is the laminate glass thickness? These are questions, and I know some of the previous speakers spoke about specifications, but it's really important. So this is a very interesting video you might find interesting.
Wow. Keep going right through. Yeah, that makes sense lashing again.
All right, that's it.
That's too lashy go through. Nah. I get my shit and they give us
Waste of time.
Nah. That is not happening. There's something wrong with it. Okay. This is for you. This is your glass. We're going to test it. This is the treats. How you feeling? You're feeling good? We will find out. You think break right through. God. Look at that. The thing going right through, man. Stop. Laminate glass. We're going to try to hit this and see what happens. But it's going to break. It's gone straight through. Look, it's gone through already. 3 hits and it's gone through. This is no good, man. That's gone through. It mash up. That's the end of that. It mash up. This is your glass. Test your glass. How you feel? It must take 10 shots of this hammer to pass. Nigel, you ready? Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nigel, you're fast.
So clearly I breathed a sigh of relief when I saw the video. and in fact, I did myself a disservice, because if you notice the window that I asked him to test, I made it too small. So I actually forced him to hit the strikes in a smaller space. So actually I made the test harder for our window, because he was striking the same area of glass repeatedly, whereas a bigger window would have had more space between the strikes. But as you can see, with the other ones, if you get a small projectile hit those glass and it creates a hole, and you're in a hurricane, there goes your building, because the wind pressure starts to build, it blows out your roof, might blow out other windows. So this really is just a highlight that not all laminates created the same. So when you are recommending hurricane rated products or hurricane resistant products for yourself, for your clients, your family, just be aware that not all laminate glass is created the same, as this video shows.
Try again? You're not getting in very well.
So you can see again, he started off with a small sledgehammer for the first strike, and then the second strike, he actually used a much bigger sledge. And again, these tests are really not probably real world tests for hurricane rating, because the real issue is wind load. And yes, projectile strikes are important, but I mean, how many sledgehammers are going to be, swung at a window? But you will get perhaps coconuts flying around, bits of tiles. Obviously, hurricane force winds will pick up projectiles, but we did realize that the majority of the projectiles are not going to be huge. Obviously, if you get a huge one, your window may fail. But again, it's just highlighting the fact that the high impact glass can take quite a bit of beating. The other thing about UPVC, it's quite green. A product that we've been selling now for a couple of years is called Solar E, and it's a pyrolytically coated glass at the factory, and it reduces the solar heat gain through the windows and doors by about 50%, which is quite incredible because we have, especially if you have big windows, nice views of the sea, nice big glazing, nice big windows. If you're an architect or a client and you have a beautiful view of the sea, you want to give them big windows. What the Solar E does, it keeps the heat at the glass. It cuts down 50% the glazing at the glass. And what we've been selling a hell of a lot recently is laminate glass with Solar E. So you're going to get the benefits of the laminates, which is sound reduction, heat reduction, UV protection, and wind load protection. And now if you add one of those panes of glass being Solar E, you're now cutting down the heat. So basically it cuts down your wind load, cuts down your air conditioning load, and keeps the heat at the window itself, at the glass. And of course, the PVC frames are inert, so no heat's coming through there. So it's providing a great level of insulation from the crib and heat. And as the slide says, it reduces energy consumption by up to 30%. If you're doing new build construction, like hotels and hospitals, which we've been involved with, we can sit down actually with the air conditioning people and the engineers and the architects. And if we've designed the right Solar E laminate glass, hurricane rated laminate glass, we can work out what the actual heat loading of the building is. And you may be able to reduce the tonnage of air conditioning required because we're now insulating the building better. And of course, as I say, it eliminates hotspots near windows and doors. The payback is incremental. Of course, Solar E could pay for itself, especially up the islands where electricity, cost of electricity is going up and is expensive. So of course, if you can reduce that cost, that's great. So this is something which we also recommend is going with Solar E now, but that's basically just a glazing product. The other thing about laminate glass is sound attenuation. It does cut down street noise, neighborhood barking dogs. Basically, it has an STC rating of 35, which means it's reducing the sound transmission by 35 dB. This next video is quite short, but it does give you a huge indication of what laminate glass can do. We did have a client of ours in Tobago right by the sea, living literally on the beach, and they had an air conditioning unit outside their bedroom, you know, the compressor or the evaporator, I always get confused which, and they had a big patio door, and when the door was open, you're hearing the surf, you're hearing the sea, you're hearing the air conditioning. You close the door, you don't hear the sea, you don't hear the air conditioning unit that's running. This is a video where we were building our plant in Trinidad, and we had quite a heavy, noisy machine compacting the concrete on the outside. And this shows you what the sound difference is between open and closed door. So you see, they say a picture or a video is worth 1,000 words. Clearly, you can see that the sound attenuation is quite a big plus. And that's basically it. So I hope you guys learned something from that. As you say, it's our pleasure to be here. Thank you for listening to us. Domus, we believe that when you're designing for hurricanes, every structure is different, every structure is unique. Reinforcing is critical. So we make sure that when we build something, we've also built a test lab at our factory in Trinidad, so we can actually do actual wind load tests ourselves and certify. So before we send something out that's interesting and unusual, we can test it first, because of course wind loads matter on the size of the window, size of the door. But that's it. So I'll hand you back over to Terence right now.
Hi. All right. Thank you, Nigel. So we have Terence in-house. We need to break for lunch, but right. Nigel, can you do me a favor and just make us the host again? Thanks.
Okay. How do I do that?
Go to participants.
Yep. Gotcha.
Participants.
Right.
Bottom right, bottom left.
I'm looking. Are you seeing my screen? Sorry.
Yeah.
Is it bottom left?
Yes. Right. Click on participants. Yes. Scroll down, find SLIA, and just
there. It's SLA. SLA.
Yeah, go to more. Make host.
So. Oh.
Yeah, I think.
Did I do it or not?
Yeah, I think we should be good there. All right. So what I would say is we have Terence here who wanted to do a bit of a smash test on the window. We were supposed to receive some new windows for us to smash up, but I think there was issues at the port, so we didn't get them cleared in time. But we do have this existing window, so I don't know if Terence wants to take a swing at it or if he's going to invite someone. I'm going to turn the camera quickly. Anyone want to take a whack? Look, we have two big strong guys there. Come. Yeah.
I see the window has been hit once before already.
Yes. I'm not sure how often it's been hit. So.
I mean, if anybody wants to ask any questions before lunch, feel free to ask now. I'm quite happy to answer a few.
Yeah.
The glass actually falls in front. Wherever he hits it, you want to have the plastic more in front of the window. Yeah. Well, or in the middle, anyway, whatever.
Guys? Go ahead, man. Go again, man. Go again.
In the middle somewhere or wherever.
Anybody else want to take a swing?
Now, eventually, if you hit it often enough times, you will make a small hole, of course. I mean, if you hit it 20 times, it may fail eventually.
All right.
Okay.
You don't want to take a swing at it? No? All right. Okay, so you want me to take a swing?
Any questions, though?
There you go, guys.
All right.
All right, so I think that will conclude the presentation by Domas. Oh, sorry, we have a question.
I wanted to ask, I know they do a lot of
You have to repeat it for me. I can't hear it.
Yeah. So he says he know you do in-house testing, but he wants to know if you all have sent it over to Miami to get tested in their facilities over there as well.
Initially, we've been around for 15 years. Initially, before we built the factory in St. Kitts, yes, we had third-party testing done. But the reason why we have our test lab is that when we're doing custom projects, especially with very large windows and doors, we do it in-house. But if we're doing a large commercial project and the client wants to do external testing, then sure. But we have done external testing. We do have test results on our windows. So the short answer is yes. But of course, when you do an external test in these labs, you're testing a standard size window, let's say a 2x4 or a 4x4 or a 8-foot wide by 7-foot tall, patio door. You can't. So whereas so basically the short answer is yes, we do have external test results. But if we're doing a special build for a client, you can't send everything. But if it's a large enough project where the client, obviously we're not going to send one window to be tested. You're buying one window from us because the test costs, a few thousand $. But if it's a large project and the client really wants us to do third-party testing, of course we can do it. But what's nice is that before we send it for third-party testing, we'll do our in-house testing first to make sure it'll pass.
Yeah. All right. Any other questions from online? I don't see any currently. So thank you, Nigel, for your presentation. I know I got some messages from online saying that on my phone, saying that they're on their website currently. So
that's good. That's good. Yep.
Yeah. So we're gonna break for lunch now. All the persons online, I'd like you to give us about half an hour break. What's that? Okay, I think they're just finishing up the setup. But so we're gonna take our lunch break now, and we should be back within about half an hour. So we will leave the meeting running, but there will be no video or audio. All right. Was there a question there? Okay. Okay. All right. So yes, as I said, we're going to take our lunch break now, and we'll be back soon. Thank you.